All right, what's up? Welcome back. We finished up episode 3. We were able to draw something on our screen, on our window, and now we're going to be working on something a little bit different. Well, a lot of it is the same, but a different idea of it. Just to kind of give a sneak preview of what we'll be doing. We're going to first scale down our little sprite image to actually accurately depict what position it's going to be on in the screen, and we're going to allow our renderer to actually dynamically render objects, so we can actually move our character around using the keyboard now. So kind of just to go over a little bit into deep dive into what I'm talking about, let me first hide my camera and we'll look at some code here. Let's go ahead and go to our game engine. So if you see in our main our main.cpp file right now, we're currently drawing from a pretty statically sourced sort of position file. So this rectangle here that we're drawing to, we can't really change it. We can't go through and change our vertices and then recompile our buffer data and then have that to draw into our array. And we could just do that all in the main file, but that's kind of cumbersome. So we're just kind of loading up our main file with more and more sort of actions and files. So it actually makes more sense to why not create our very own render file. So to do that, let's first define what a rectangle is. In my definition, well, we're not going to be like Webster's defining it. We'll be defining it in code so the computer knows what it is. What a rect is, it's going to be a struct rect, and it's going to have a float, an x position and a y position, as well as a width and a height. So it's going to be your simple rect sort of definition right there. And the next thing is, let's go ahead and start working on our renderer file. So let's call this renderer.h. And let's start including a few things. We're going to need GL generics. Let's go ahead and include clad.h. And then we'll also need vector. So we're going to replace what we have here with vertices being just an array of floats with a more dynamically sized array called a vector. And so we can just store more objects inside of it and do more things with it. So let's go ahead and start off by defining our class renderer here. And inside of our class renderer, we're going to need, if you remember correctly, our VBOs as well as our VAOs. And if I can spell GLUnt correctly. We're also going to need @size, so this is going to be important in case we want to change out our attributes. So if you remember in our main, we defined a bunch of attrib pointers. This is for our VAO, or I think it was for our VAO. It might be for the BBO, to be honest. I'm not entirely sure on that. But anyways, we defined attributes which we will be using to draw to our different shader functions. We're going to be doing that, except we're going to be doing it in a render function to be a bit more usable. So if we want to change our attributes so that they're different, say we have a shader file, sprite.vs, and we add another coordinate here, so it's layout, I don't know, whatever, vec2 color maybe, or something. Or maybe we want to add a third dimension. Position is now a vec3. We can actually do that in our renderer. We just have to create a new renderer function and work with it from there. So to do that, for my particular implementation, we're going to be using @size to get our render function to work correctly. And the last thing that we'll need is our standard vector of GL floats. We called it vertices in main function. We're going to just call it buffer here because the code which I copied the idea of this renderer from used buffer. So we're just going to use buffer as well. And don't worry, I didn't completely copy this guy's code, although I probably should have, as My code's probably not as efficient as his. I added my own sort of spice to it, so we'll be using this sort of amalgamation which I created here. The next thing we'll need the constructor, so let's go ahead and define the constructor here, like so, and our deconstructor, and we'll go ahead and implement these in renderer.cpp very shortly. And the last two functions that our renderer is going to need is one is our draw function, so this is where we update our different recs or just add to our buffers. So we're going to have a rect dest and a rect source. Now, if you remember from the previous episode, I hate just bringing up this main function all the time, but it's kind of important. We have two different rectangles that we're actually using to draw. One is where we're drawing it from like the image side. So like for this case, we're just drawing the entire image. So this is the bot left of the image, which is at 0, then the top right at 1. So these are the position source coordinates under the chords column here. And then for our actual dest, which we're drawing from, or we're drawing onto the screen with, we're using this rectangle here. So we're going to need two different rectangles to draw from to create this entire vertices thing, or push back this rectangle into our renderer. So we'll be doing it like so. I guess we didn't include rect. That's another thing we'll need to include. And lastly, we'll do flush. And what flush is going to do is it's going to flush out everything that we've drawn using the draw function onto our OpenGL buffer array that we set out and defined and everything. So let's go ahead and create our renderer.cpp. So to do that, pretty self-explanatory. Go through Visual Studio's nonsense creation tool. And let's go ahead and implement these functions: the constructor, definition, deconstructor, definition, draw, flush, yada yada. Get those out of the way. And let's start off by implementing our constructor. So the first thing that we'll do is set our VBOs and VAOs to 0, just so that they don't have some garbage data from a previous session inside of them. And let's go ahead and start by just copying and pasting over the stuff we did in mains.cpp. So let's go ahead and grab all of this and move this into renderer here. Now, if you remember me talking about in the start of the video, we are going to be redefining the buffer data every single frame now. So instead of statically at the beginning. So what we did here, we just kind of statically did that there. We're actually going to be moving this into our flush function. So let's go ahead and just move that there, and we'll deal with that later. Let me see if I'm still recording. I am. And let's start just replacing, because we now have an underscore, and just how I write my code, I have underscores for my private functions, and I don't need to re-explain these sort of things. Oh, I forgot to copy and paste the other attribute pointer, but that's not going to be a big deal because we're going to be doing something else with this anyways. So as I said, we want to make it so we can add like any sort of attributes. That's why we have this vector of ints here, of attributes here. The first thing that we'll need to do is calculate the attribute size. So what the total, so each of these attributes, like for our particular program, it would be like an attribute, like a vector of 2 and 2. So that would be 2 floats for our source position, or sorry, a dest position, and then 2 floats for our source position. But our total attribute would be 2 plus 2, or 4. So we have to calculate that as well. So to do that, pretty easy sort of function here. We'll just do a simple for loop going through all of our different attributes. Start off by zeroing out our attribute size. And then creating our for loop for auto at in attributes. At size plus equals at. Pretty simple sort of function there. And the next bit is we're going to be creating different attribute pointers for each of our attributes. So we'll need another for loop here. So for auto I equals 0, I is less than attributes dot size. And I guess since dot size is an unsigned long, we can just probably should define that as an unsigned long as well, just for easier comparisons. And let's go ahead and copy paste this in here. So we have to just go about and replacing all these different undefined variables like 2 and 0 with what we defined with our attribute and attribute size. So for one, this is going to be I, and this is what is set up to our location. So I guess one thing to note about our renderer, it doesn't work if the locations are not in 0, 1, 2, 3, 4, ascending order like that. So there's something to keep in mind. If you want to put in your own custom shaders, you'll have to either fix this function here, or just make sure the locations are lined up in 0, 1, 2, 3, etc. The next thing, this is this 2, that's going to be attributes at the I position. So if it's at 0, it's going to be 2 for our 2, 2 example. And then this 4 times the size of GL float, that is just going to be our at size. So what we calculated is an at size. And notice how this is a private variable and attributes is not actually saved anywhere. So we're actually going to be using at size in our flush function as well. So that's why we're storing it. And then lastly, this 0, we're actually going to have to define another variable here, and we're going to call this stride. That's going to be equal to 0 unsigned long. That's going to be our stride, so every single time we increment our attributes, we have to figure out how many, what stride length we're on inside of our attribute array. So to do that, we'll also, inside of our for loop, we'll have to plus equals stride every single iteration with the size of GL float multiplied by attributes at I position. So that should get everything sorted out correctly, so we can actually just be done with this here. At size is undefined, but we define it here. I guess I think these are integers. I don't actually remember. Let's just work on our deconstructor now. We'll deal with those like tic-tac-y errors or warnings at another date. In our deconstructor, we're just going to check to see if the VBO is defined. So if it's not 0, and then if it is not 0, we want to excuse me. We want to delete the buffer. So to do that, we just call GL delete buffers. We only have one buffer here, so we're just going to pass through our buffer that we want to delete, and then do the same for VAO. Do that like so. And then we'll just zero out VBO and VAO, just so they don't get mistakenly used again, even though that we deleted the buffers inside of them. So now we're kind of onto the tedious part. So we have to move over like the bot left from our position and coordinates, the top right for our rectangles. And I'll go ahead and I'm going to go ahead and do like the first couple, and then I'm just going to copy and paste the rest because it is, as I said, very tedious. But we're just pushing back to our buffer vector that we created in renderer.h. So this thing. So instead of using this array, I already went over this. Let's just go ahead and just go through and do it. Buffer.pushback dest. So we're starting off with our dest position. So it's going to be dest.x if we're going for bot left. Bot left is, just dest.x. And then our bot left y position would be dest.y plus dest.h. And then it's just mirrored for our source, so we can just copy and paste that, replacing dest with source here. And then let's work on our bot top right. So luckily we've created some comments here to make it easier on ourselves. So let's work on our top right here. And top right would be dest.x plus dest.w. And then just dest.y for that. So this is going to mirror the top half here. And then I'm just going to copy and paste the rest. So we're just going to go down in order, top left, bot right, whatever, whatever. And I added some comments as well just to make things a bit more readable. So this is obviously just going off my notes here. This is all will be available obviously in the GitHub, so if you want to look that over, but it's pretty self-explanatory. I'll just scroll down slowly in case you want to just copy it from the video. So we don't need the mean anymore. We can just go back to what we're at, but our draw function is pretty much completed. You notice how like we're just kind of adding rectangles to our buffer. This just allows it so we can render multiple objects on the screen. Obviously for right now we're only rendering using one image since we're only binding to one image at the moment, but in the future we'll update our like texture and shader files to be able to access with like different shaders and different images to make things a bit more unique and fun. Well, and to actually like make a game. All right, so let's work on the flush function. So instead of size of vertices here, we're going to be using the size of GL float multiplied by our buffer size. So this dot buffer dot size. Now notice we don't want to do the size of our buffer since it's as a vector. The actual array is going to be much larger than what the actual amount of data that's in the array. So we need to make sure we do it in this way. So don't use size of this dot buffer. You are not saving lines of code. This is unfortunately just how you have to do it. And then the vertex, the start position, you could do the reference to buffer at 0, or you can do this nifty little function here, this dot buffer dot data. So that should solve the starting position for our buffer. And the next bit, we need to copy from our main. We closed out of it. This function here, GL draw arrays. So let's go ahead and move that in. Except we have to replace the 6 since we don't know how many points we're going to be drawing. So originally we had like a static solution, so we had 6 points for 2 different triangles that we would be drawing to. And in this case, we got to calculate the amount of points. Let me see if I have the function here. You have to do this function right here, this dot buffer dot size, and that is divided by the attribute size. So that should get us how many points we need to draw. So that's why we save the attribute size. That's why everything works so well. Lastly, we'll have to clear the buffer so that we can add new data to it every single frame. And we finished our renderer. Isn't that really cool? So let's go ahead and implement this in our main so we can play around with it and see if we can actually render a sprite again to the screen. So let's go ahead and include renderer.h. We can delete a lot of this. Let's delete that, delete that. And I guess we should probably define renderer first. So let's go ahead and define that renderer. Oh, I need to actually add a standard vector here. So it's going to be 2 and 2 for attribute sizes. So that should load in the same sort of like setup that we had prior. And let's go ahead and define some recs here. So rect, let's just call this dest, and that's going to be, can I just do it like that? I think I can. What do we have? It's like 0.5, negative 0.5, negative 0.5, and then 1 and 1 for width and height. And then our rect source is going to be 0, 0, 1, 1. So this looks awful. So you don't really get a good idea of where this is going to be on the screen, but I promise you this is I think this is the same setup that we had before. Yeah. And then the next bit that we need to do, see, we've created our renderer, we have to flush out our renderer and draw. So let's go ahead and draw, dest source, and then renderer dot flush, and that should redraw our buffer every single screen or every single frame. And let's see, we got our sprite on the screen. Is he still there? Oh. Oh, whoops. It looks like we got a GL error. Look at that. So it looks like me re-recording this. Yeah. Forgot to delete. Ooh, that projection. That's. There should be nothing wrong with your shader. Honestly, you're probably your thing probably ran just fine. I did a recording where I worked on something called projection, which we will be going over in the next episode. But I decided to split it up a bit differently because the episode went a bit longer than I thought it would. But anyways, this is what we have for now. So our renderer is now working as intended. But I mean, obviously right now, if you look at the sprite, here, I'll move on the camera so you can see me again. If you look at the sprite, it's kind of stretched out horizontally more than it is vertically, because we are drawing it to like a pretty rudimentary, like sort of in just like a not optimal way. So in the next episode, we're actually going to change that so that we can draw it based off of like what the window is, so the actual pixels to the window we can actually draw towards, so we don't have to deal with these like nonsense numbers like a rectangle of negative 1/2 by 1/2 with a position of or a width and height of 1. We can actually set up to the actual dimensions that we want it to be. All right, but that is going to do it for this episode. Thank you so much for watching. We will go ahead and finish up where we left off and get our guy moving around shortly, but I'm going to be calling it for now. So thank you so much for watching, and I'll see you in the next episode.